So this is a little instruction sheet for how to draw dot diagrams that are like the homework that I gave you. However, these are different dot diagrams following the same set of rules. So I'm going to use something different so that I'm not actually doing them for you. So I put the rules that I gave you in class over here. The first thing you need to do is add valence electrons. I'm going to start, we'll just start with oxygen. You guys breathe oxygen, so we might as well draw a dot diagram for it, then you know what you're breathing. So let me click on my little marker icon, and here we go. So we know that oxygen has a total of 12 valence electrons. I don't know if I can show you that quickly or not. Let me see. So that's our homework. I'm going to put it on here. If I go here, and I click on the periodic table, you can see that oxygen right here has 6 valence electrons, and there are 2 oxygens in this formula. So I'm going to have 12 valence electrons for oxygen. So I'm going to put 12 here. Oops, that's supposed to be a 12. All right, there we go. So now we put an O and an O in a little box. And of the 12 valence electrons, you'll notice that there are 2 already in the picture. Then you say, wait, where are the dots? Well, remember that the line counts as 2 electrons, and they count for each atom to which they are attached. So I'm going to take away 2 electrons, and I'm going to have 10 electrons to put in. So I put in 1, 2, 3, 4, 5, 6, and then I put in 1, 6, and then I put in 1, 2, 3, 4. Now you can see I've got a problem because I put in my 10 electrons, and I don't have any place else to put them. So, I don't have any more electrons to put in because I put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how many I had to work with, but I still need 2 more right here that I don't have. So then you go back down here. If there's not enough electrons to put 8 around everything, add a double bond to start over. If you're too short, you add 1 double bond. Well, in this case, all we can do is add 1 double bond. So I'm going to put it up here. You wouldn't do this. You'd erase it and put it in your box. All right, so now I had these 12 electrons. I'm going to take away 4 instead of 2 because now I have 2 lines, and each line counts as 2. So that leaves me 8 electrons to actually distribute. When I distribute the 8 electrons, I'm going to have 1, 2, 3, 4, and that gives me 1, 2, 3, 4, 5, 6, 7, 8 around that oxygen, and the other 4 of the 8 electrons that I had over here go on this side. So now everything has 8, and it turns out that you're breathing oxygen molecules which have a double bond. Now let's take a look at HCN. This is a different one. So we're going to add the valence electrons up. Hydrogen, carbon, and nitrogen. So if I click over here, and hydrogen has 1 valence electron, carbon has 4 valence electrons, see the 4 right there. Nitrogen has 5 valence electrons. So we go back over here. We'll close this guy out, come back over here. So what did I say, 1, 4, and 5, right? Doesn't that make 10? So we have 10 valence electrons. So you set up your structure, H, and then C, and then N, like that. So of the 10, how many is in the picture? 4. So you take away 4, gives you 6. So I need to put 8 around everything except for hydrogen. Hydrogen only gets 2 electrons. So we'll go ahead and put them in. So we get 6. So if I put in 1, 2, 3, 4, 5, 6, that makes 8 electrons around that nitrogen, and that's good, but the carbon is short, and I put in all the dots that I have to put in. So you see these empty spaces right here. I need 2 electrons in each one. So now I'm 4 short. Well, the rules say if you're 4 short, add 2 double bonds or a triple bond. You understand why I'm 4 short? I need 2 here, I need 2 here, I don't have them, so I have 4 electrons too few. Now, you'd like to add double bonds if you can because they're more symmetrical, but you cannot put a double bond on a hydrogen, so you can't put this. That would be wrong. Why? Because hydrogen can only have 2 electrons, and that would give it 4, so that would be wrong. So let's redraw it, but this time use a triple bond. Whoops, supposed to be a C in the middle, and then triple bond to N. All right, so now we have 2, 4, 6, 8 in the picture. So you take away 8 electrons, 10 minus 8, that only gives me 2 electrons. So I put them right here on this nitrogen. Does that make 8 around the nitrogen? 1, 2, 3, 4, 5, 6, 7, 8. 8 on the carbon. 1, 2, 3, 4, 5, 6, 7, 8. 2 on the hydrogen. 2. We're done. All right. So now let's talk about the, we'll do the rest of the sheet. Then we'll come back and do one more dot diagram and call it good. Okay, so the domains around the center, we said if there are 2 atoms, you didn't have to do that, or this. So the molecular geometry on this thing has to be just a straight line, because there's only 2 atoms. So your picture would be that. The bond type would be nonpolar because the electronegativity of the oxygen atoms are the same. And the type of the molecule, then, anytime you have nonpolar, the molecule is nonpolar, with a few exceptions that we won't get into here. All right, so now let's take a look at HCN. How many domains around the center? There's a domain, there's a domain, and there's a domain. So 2 domains. Remember, a domain is where the electrons live. A triple bond or a double bond or a single bond, they all count as one domain. So that's a domain, that's a domain. There are no unshared pairs. Lone pairs also count as a domain, but there aren't any here. Okay, so electron domain geometry with 2 pairs, if you go down to this little sheet that I gave you, if there's 2 pairs, it's linear. So we go back up here. That means the electron domain geometry is linear. Going back to the sheet, if there's no unshared pairs, then the molecular geometry is also called linear, and the bond angle is 180. What that means is there's 180 degrees. Oops. There's 180 degrees right there and right there. All right, so that bond angle is 180. Now let's talk about polarity of the bonds. You're going to have to go back to that sheet because I've got a limited size screen here. But the nitrogen's electronegativity is 3 and the carbon is 2.5. So what's the difference? That's 0.5. So that falls into the polar range, and the HC is nonpolar. So basically what's happening is the electrons are going to move toward the nitrogen in that direction. So that makes the molecule polar. The nitrogen end is going to be negative, okay, and the hydrogen carbon end will be more positive. So let's go back to this bond type for a minute. The difference in electronegativity between the N and the C is 0.5. Between the carbon and the H, it's 0.4. Okay, so really the CH bond we'd call nonpolar, and the CN bond we'd call polar. Okay, so really should differentiate. So C to N would be polar. Then that makes the molecule polar because you have a mix of nonpolar and polar, or if you look over here, the electrons move toward the N. So that is a polar molecule. All right, we're going to do one more down here. Oh, I forgot to draw it. So this, since this is 180 degrees, it's going to be a straight line. All right, so let's take a look at PCl3. We add our valence electrons, and trust me on this, phosphorus has 5, chlorine has 7, but there are 3 chlorines. So the total number of valence electrons is 26. So you'd put your P in the middle because it's closest to the middle of the table. You put the Cl's around it. And we have, of the 26, how many's in the picture right now? Be 6. So you have 20. Do you see where I got the 6? 2, 4, 6. So I have 20 dots to put in. So if I put in 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. I've now put in 18 of the 20 dots. I have set it up so that I have 8 electrons around every atom. So 2, 4, 6, 7, 8, 2, 4, 6, 7, 8, 2, 4, 6, 7, 8. That's 18. I had 20 to put in, but look, my phosphorus still needs 2 more. So they go right there, up on the phosphorus. All right, so the domains around the center, we remember lone pair counts as a domain, so there's 1, 2, 3, 4. We've got 4 domains around the center. The little sheet back here that's hiding will tell you that if you have 4 domains around the center, that you're looking at a tetrahedral situation. And of those domains, I'll remind you that there's 1 lone pair, so it's trigonal pyramidal, and the bond angles are basically 109.5. They're actually slightly smaller than that. We won't get into that here. All right, so electron domain geometry, trigonal, pyramidal, or pyramidal. The molecular geometry, oops, did I make a mistake? That should be there. And over here, we would have tetrahedral because there's 4 of them. That's really one word spread out for you. Okay, I don't know how to undo that, so we'll just leave that there. The bond angles will be about 109.5. Now let's talk about polar versus nonpolar bonds. The electronegativity of phosphorus, hang on, I gotta go look at the chart. I think it's 2.5. I'm wrong, it's 2.2. All right. So 2.2 is the electronegativity of phosphorus. So we'd have P is 2.2 and the Cl is 3.0, so the difference is 0.8, so that falls into that polar range between 0.4 and 1.67, so that's going to be 1.7, so that's polar. All right, that makes the molecule, let's see, do these, the picture is going to look like this because it's the pyramids. Let's draw the picture and I'll talk about the polarity of the molecule. There's a picture. It's like a little pyramid thing with a triangular base. So this is negative on the chlorine, we said. So you got negative, 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 or negative, negative, and that was negative. So the center of that would be at the base of the pyramid, somewhere in there. Since chlorine's more electronegative, that means the phosphorus is going to be positive. Electrons are going to leave it. So, is the center of negative down here, here, and the center of positive up here, are they in the same place or different places? They're in different places. So that makes the molecule polar. All right, so you need to finish that sheet. And the last 2, remember I said I give bonus points. And that's the end of this little video. Kind of rushed, but hopefully that did it. And there's another video that I posted as well that I made last year, which has 3 other examples in it. All right, that's the end.